Hello everybody, let us continue our chapter 6. Right now is the section 6.5. Okay, so previously for your single variable function you can find the derivative using the so-called chain rule. If your y is a function of u and your u is a function of x, then the y by dx, okay, because actually your y finally is depends on the inside variable x, right? So dy by dx can be found by using dy by du first, so as a derivative of this function first multiplied by a derivative of u with respect to x. Okay, so what it seems is that it looks like this du and du cancelled, and what you end up with is the one that you like to find on the left hand side. Okay, so now for the several variable function, what will happen if your z depends on u and v, okay, two variable, and your u also depends on another two variable x and y, your v also depends on another two variable x and y. So if you draw a diagram, it look like that your z depends on u and v like this, your u depends on x and y, your v also depends on x and y. So it means that actually your z depends on x and y as well. So what you can find is the dz by dx, a derivative, a partial derivative of z with respect to x. However, if you look at it, you see that, hey, it will be two ways, right? Two ways to reach this x. You see, one is through the u, one is through the v. Then what are we going to do? Same thing, if you want to find a dz by dy, you got two ways to reach the y. So what we are going to do? So we are going to go into the details about the chain rule, okay, for the several variable functions. So let us start with the simple case first. The first one is that your y is a single variable x, okay, it's a single variable function, depends on the x alone. However, the x depends on r, s, and t, okay, the x depends on r, s, and t. So if you draw a diagram, you can say that, hey, your y depend on the x, but your x, okay, depend on these three things, r, s, and t. Okay, so it means that if you want to reach the r, so actually your y is a function of course the r, the s, and the t, right? So if you want to find a derivative with respect to r, okay, and this one we use the curve to indicate that your y actually regarded as a function of several variable r, s, t. Okay, so you need to go through the x first, and then from the x you go through the path to your r. So this one, it means that, when you see the diagram like this, it will be a lot easier. You can write down the dy by dx first. You see, dy by dx first, followed by dx by dr right here. Okay, and what you can see is that it seems, okay, it just seems to be that the dx and dx cancelled, and what you have left is the one that you would like to find on your left hand side. Okay, however, in terms of notation, it has a little bit different. Okay, for example, at this moment your y regarded as a single variable function x, so you are going to use a straight d, okay, to determine that, hey, right now your y depends on x alone. But if you keep looking, your x depends on three variables, so your x is a several variable function, so we are going to use the curve. Okay, so we use the, instead of a straight d, we use a curve, so you have a curve x by curve r, just like that. Okay, so if you want to go through the s as well, so we are going to go through the dy by dx first, and then followed by dx by ds. So you see this d by dx seems to be cancelled, and you end up with what you need on the left hand side. Okay, So if you want to go to the t, so you go to this path dy by dx followed by dx by dt. So here as you multiply, the dx and dx seems to be cancelled, and then what you end up with is the one that you need on your left hand side. Okay, so this is the simple case first. So let us go through the example. So now your y, you see, depends on the x alone, but your x depends on r, s, and t like this. If you want to find y sub r, okay, the derivative of y with respect to r, or the dy by dr, okay, so it's going to be the dy by dx, okay, as we have it here, and then dx by dr, okay. So as a dy by dx is a derivative of a square root of x, so you have a 1 over 2 square root of x, and then dx by dr, it is 2r, okay. So you got a r over a square root of x, okay, and you don't really need to replace your x by r, s, and t, okay. We are going to indicate on the problem explicitly that the answer can be in terms of, you know, the answer in terms of x, r, s, and t. So you don't really need to replace your x by r, s, t. Otherwise, it has no point to using the chain rule, is it? So how about your y sub s, or the dy, the derivative of y with respect to s? So you have to go through again x first, and then dx by ds, okay. So the one that the derivative with respect to x of the y, you already found it, and then the x with respect to s, now it is 8s cubed, okay. So it is 4s cubed over square root of x. And the last one, derivative of y with respect to t, dy by dt. So you go through the x first again, and then dx by dt. So go through the x, you have the same thing, but then dx by dt, it is 6t. So you have 3t over square root of x. That can be your final answer. Can you notice something? Okay, this one, dy by dx, always appears, okay, in each and every partial derivative that you would like to find, you see. So it means that this one, you can find it only like one time, and then you can keep using it, okay. The only thing that will change in each and every problem is this one. Either you do it by dr, or you do it by ds, or you do it by dt, okay. That will be the one that change, okay. Of course, I mean, this one, like your y depends on the x alone, and then your x depends on some other variables. It can be converse, right? It can be converse. For example, this one, your w depends on 3 variable x, y, z, but each of the variable depends on the only single one t. So actually your w immediately a function of, I mean, eventually is a function of t alone, only a single variable, okay, a single variable. So it means that if you need to go to the variable t, you are going to find the so-called dw by dt, and you use a straight d, because right now it's a single variable t, you see. And to reach this t, okay, you can go by 3 ways, okay. First, you can go by dw by dx, and then dx by dt. This is the first possibility. The second possibility is to go through the y, and then follow dy by dt. The third possibility to reach the t is to go by the z, okay, dw by dz, and then continue with dz by dt, okay. So this is like a combination, okay, a combination rule, okay. If you want to reach the t, you can go by 3 ways, okay, 3 different ways. So each of the 3 ways, okay, will be add up okay, like this, okay, will be add up like this. So the addition here, it simply mean like or, okay. So if you want to go through the t, you can go through the path that passing x, or the one that passing y, or the one that passing z, okay, and each one of them will contribute. You see, it seems to cancel, right? Each one of them, each term will contribute the dw by dt that you need on the left. You see this one dw by dt, and this one also dw by dt, okay. So each contribution will give you the one that you need, okay, only each contribution, and don't look at it as a really addition, okay. So let's take a look at the example. This one, your w depends on x, y, and z, okay, and your x, y, and z depends on a single variable t. So your dw by dt will be the one that we use chain rule. So dw by dx by dt, okay, and then you can notice the way we use the notation, right? Because right here we use a curve, because your w depends on, you know, 3 different variables, but there we use the straight d, because each of the x, the y, and the t depends on only the same a single variable t, okay. So this one dw by d, you go through the y path, and then dy by dt, and then you go through the z path, and then dz by dt, okay. So each one of them, for example dw by dx, so you look at this one, okay, don't forget that you have a 2, okay, and then a 0 for the second term, but then the last term with respect to x, you got a z, and then dx by dt, you have 2t plus dw by dy, the first term goes away, the second term survive, and then the last term also goes away, and dy by dt, you got 12, and then the last one dw by dz, the first term goes away, the second term also, but the last one is x, survive, and then the dz by dt, it is 12 t cubed, okay. And then you just, I mean, that will be good enough to be your final answer. You don't really need to simplify anything, or I mean, if you want, you can do it this way, but you don't really need it, okay, because they are in a different what should I say, they are in a different level of variable, okay. Here's a variable x, y, z, and there is another level variable t, okay, but you don't really need to change it, okay. Just keep it like that. That will be good enough to be your final answer, okay. So now let us go to the one that we introduced at the beginning, okay, the one that may be a little bit complicated, okay, because now your z is a function of 2 variables, x and y, and further your x is also a function of r and s, another 2 variable, your y is also another 2 variable, r and s, but you use the same idea. To reach the r, there are 2 possibilities. One is through the x and then go from x to r. Second one go through the y and from y to r, and then you are going to combine these 2 possibility together. So you are going to have your dz by dx followed by dx by dr. You see the first term was the contribution after this one seems to be cancelled. You got dz by dr for the first term, for the first possibility, right? And for the second term, you find dz by dy followed by dy by dr, and after it seems to be cancelled, okay, the one that left over is dz by dr as well, okay. So the first contribution gives you dz by dr. The second contribution also gives you dz by dr. Okay, that's the meaning. So this one is like a combination. Okay, so on the other hand, if you want to go through to reach the s, you are going to go through the dz by dx, dx by ds, or dz by dy, dy by ds. Okay, and then you combine them. Okay, you combine these two possibilities together. Okay, so dz by ds, it is dz by dx, dx by ds. Okay, these two seems to be cancelled. As you see, the leftover is dz by ds that you want to find, and also in this term dz by dy, dy by ds, and the dy and dy seems to be cancelled, and this is what you want to find. Okay, and they just combine. Okay, they just combine, not really addition. Okay, and we have a name for it a little bit. I mean, instead of using the symbol dz by dx, sometimes we use the f sub x, and instead of dz by dy, sometimes we use the f sub y. Okay, so the chain rule can be written in this form. Okay, in this form, and this form can be viewed as a derivative of the z equals to f of xy. Okay, and both are I mean depends on the dx by dr and depends on dy by dr. Okay, so this derivative, okay, this form usually is called a total derivative of z with respect to r. Okay, so it is the sum or is a combination of two contributions, as I told you. The first term is the one through the x, and the second term is the one through the y. Okay, so of course, similarly, if you want to find a total derivative with respect to of z with respect to s, then you use the other way around, right? Of course, I mean go through the x path and then the derivative with respect to s, and go through the y path and the derivative follow with respect to s. Okay, so let's look at this example, and I'm not so sure whether it helped you or not, but usually diagram help me to find to write down the formula for the chain rule. So your z depends on x and y, your x depends on r and s, your y also depends on r and s. So if you want to find the z sub r or dz by dr, so you need to reach it to these two possibilities, right? So you are going through the x path and then dx by dr. Okay, follow, you see this one, and then you are going to go through the y path followed by dy by dr. So dz by dy and dy by dr. Okay, so what's your dz by dx? Look at this one. So you got 2x and 0. What's your dx by dr? So you have the s, and then dz by dy, you look at this one again, you got 0 and 5, and then dy by dr, you look at the y and you got a 2, and this one will be good enough to be your final answer. Okay, no need to simplify anything, and no need to replace your x into the r and the s. How about the z sub s? Okay, it will be dz by ds, which is the one that is go through the x path. So dz by dx and dx by ds, and the one that go through the y path, dz by dy and dy by ds. Okay, so your dz by dx, it is 2x and 0. You look at this one, right? And then dx by ds. Okay, so you got the r. dz by dy, you look at this one again, so it is 0 and 5, and then dy by ds, you have a 3. Okay, again, as you may notice that this one and this one will appear, okay, both on your z sub r and z sub s. Okay, so it means that you will calculate these two quantity once, and then you can use it, continue using it, Okay, the one that it will change, it will be the dx by dr, dy by dr, dx by ds, dy by ds. Okay, that this will be the one that change, depends on whether you are finding a derivative with respect to r or with respect to s. Okay, how about this one? Let us draw a diagram first. Your z depends on x and y. Your x depends on r and s. Your y also depends on r and s. So this one is the same as previously. Your z sub r, or dz by dr, it is dz by dx. Okay, this one is just for you guys to make yourself familiar with the formula. Okay, that you have two contributions, okay, through the x and through the y with respect to r. Okay, so the dz by dx, of course, you look at this one, it is 5x fourth, and then dx by dr, you look at this one, so you have 2r. dz by dy, you go back to this one, you have a 2, and then dy by dr, you look at this one, which is a 6. Okay, how about the second one that you need, dz by ds? Okay, so it is a dz by dx. Okay, you see, through this path and also through the y path, dx by ds, dz by dy, dy by ds. And don't forget that here they are pretty much the same, so you don't need to calculate anything. Only the one that you need to calculate is dx by ds, which is -3, and then this one as well, they are pretty much the same as the one previously, so you can just copy it down. I mean, if you did it right at the first place, then you will have the right one, okay, to use. And then this one, you look at this dy by ds, so you have 10s, and this will be good enough to be your final answer. Okay, I mean, in our problem will indicate pretty explicit that the answer can be left in terms of variable x, y, r, s. Okay, x, y, r, s can be just leave it like that. Okay, or you are going to like to find a derivative at some particular point. Okay, for example, if you want to find the dz by dr, okay, whenever your r is 0, your s is 1, let's say, okay, then it means that I mean, this one you can just replace your r, right? But no s to replace. But what is your x and your y? What's your x and your y? Then you need to know by yourself that, hey, if your r is 0, look at it here. When your r is 0, your s is 1, your x will be -3 and 4, which is 1, and your y will be 5 and 1, which is 6. Okay, then you can just replace your x and your x by 1, your y by 6, okay, into your formula here, either here or there. If you want to find the dz by ds as your r equals to 0, your s equals to 1, also you can plug in your x to be 1, your s to be 1, and then you can figure what number that you end up with. Okay, I mean, this is, you can imagine, right? If you are considering w depends on 3 variables at the beginning, and then each of these 3 variables depends on r and s, r and s, r and s. So if you need to reach the r, you got 3 possibility: the one through the x, through the y, and through the z. So each one of them you are going to combine. Okay, so the first one is a dw by dx and then dx by dr, and again you may check whether you did it right or not by just pretend to cancel these two, and you need to end up with the one that you want on the left hand side, okay, on each of the term that you combine. You see, this one dw by dr, this one also dw by dr that you need. Okay, how about this one? If you want to go through the s, you need three way, right, through y to through x, through y, and to z. So it is a dw by dx, dx by ds, dw by dy, dy by ds, dw by dz, dz by ds, and then they just combine each other, okay, each contributions. Let's look at this example. Okay, this example is not that difficult. Your w depends on x, y, z. See the z. Your x depends on r and s. Your y depends on r and s. Your z depends on r and s. So if you want to find w sub r or dw by dr, let me write again. So it is dw by dx, dx by dr, dw by dy, dy by dr, and dw by dz, dz by dr. Okay, so it is through the x path, through the y path, through the z path. Okay, so dw by dx, you look at this one, so you have a y and a 4xz, and then dx by dr, you look at this formula. How about dw by dy? You go back to this one again, so you have the x, and dy by dr, you have to look at that formula, which is 2r s cubed. Okay, then dw by dz, you go back to this one more time, so you have 2x squared, and then dz by dr, so right here, which is 4. Okay, it's not that difficult, right? So how about the w sub s? It is dw by ds, or just write one more time to get yourself familiar with dw by dx, dx by ds, dw by dy, dy by ds, and dw by dz, dz by ds. Okay, so what is it that they are the same? You see, dw by dx, so you can just copy if you did it right at the first place. Okay, dx by ds, here is this one, they are pretty much the same, right? dw by dy, so you can just copy. But dy by ds, you look at this one, so you have 3r squared s squared, and then dw by dz, of course, I mean, they are the same, right? So you can just copy 2x squared. dz by ds is right here, -3. This can be good enough to be your final answer, don't forget. Okay, no need to simplify anything. Are we all right? And actually this kind of, you know, chain rule like this can be applied to some kind of word problem as well. So this one, it says that a manufacturer of a camera and a film, okay, saying that the total cost of producing a QC camera and QF units of film is given by this function, okay, 30 QF and 0.015 QC QF plus QF and add 900. Okay, however, the demand for the camera is given by this one, 9,000 over the price of a camera and the square root of the price of the film. And the demand for the film, it is 2,000 minus the price of the camera minus 400 times the price of the film. Okay, so of course, I mean, the PC is the price of a camera, the PF is the price of the film, 1 unit per unit. Okay, you need to find the rate of change. So let us highlight the question, the rate of change of the total cost, okay, with respect to the price of a camera. Okay, so can you interpret what they ask in terms of notation? So this one, what is it that you need is the rate of change. So it is a derivative of the cost, but then it is saying very explicit that with respect to the price of the camera, so with respect to the PF. Okay, however, if you look at it carefully, it's saying that your C depends on two quantity, the quantity of the unit of a camera and the unit of a film. And also a camera depends on the price of itself and the price of the film. The quantity, the demand of a film depends on the price of the camera and the price of itself. Okay, so if you, oh sorry, this one I put it wrong, it is the price of the camera, okay, the PC. So if you want to find a derivative of the cost with respect to the price of the camera, so it's over here, right, the price of the camera. So you need to go through two paths, the one through the quantity of a camera and the one through the quantity of the film. Okay, so this one is just simply the DC, the QC and the QC with respect to the price of the camera. So this is the first contribution, and you are going to add the second contribution, the derivative of the cost with respect to the quantity of the demand of the film and the demand of the film with respect to the price of the camera as well. Okay, so this one, you look at this cost function, right? Okay, a derivative with respect to the QC, you have the first term 30 survive, you got the second term 0.015 QF, right? Because your QC is a variable right now, and the rest they are all zero. Okay, how about if you look at the demand of the camera with respect to the price C? So it means that your 9,000 over a square root of PF has nothing to do, right? And the derivative go directly to 1 over the PC, which is -1, and then PC raised to the power -2, right? And then you add another contribution, the derivative of a cost with respect to QF. So you look at this one again, but this time is depends on the demand of the film. So the first term goes away, the second term, the derivative go directly to Q sub F, so you end up with 0.015 QC, and then this one you still have a 1, and then the rest they are all 0, and you are finding the derivative of the demand with respect to the price of the camera. So you look at this quantity, right, this function, this one goes to 0, this one it is -1, this one also goes to 0 because there's no PC. Okay, so this is the rate of change. However, you need to have this rate of change when the price of the camera is 50 and the price of the film is 4. Okay, so this one you can replace it by 4, this one you can replace it by 50. Okay, however, what is the QF and the QC? So you just calculate. Okay, for example, if you look at QF, whenever your PC is 50 and your PF is 4, so you have a 2000 minus 50 minus 400 multiplied by 4, it is 60, 1600. Okay, so you are going to end up with what, 2000 minus 1650, you end up with 350. So let me put it here, 350. Okay, how about this one? This one, it is 9,000 over the price of the camera and the square root of the price of the film. So it is actually 9,000 over 100, so it is 90. Okay, it is 90. So it means that your DC derivative of the cost with respect to the price of the camera, whenever your PC is 50, your PF is 4, it is 30 plus 0.015, and then your QF, it is 350 here. Okay, and then multiply by, okay, let us multiply it here, multiply by 9,000 over negative, the square root of 4, and then the negative, right, because you have a negative here, 50 square. Okay, this is the first term, multiply, and then you add the second term, which is 0.015, and then your QC, which is 90, and then plus 1, multiply by -1. Okay, and then the rest, it just like using either your calculator or your brain, it doesn't matter, right? So let me just use my calculator. 0.015 multiplied by 350, you got this one as 5.25. so it means that your DC by DPC at this 50 and 4, it is 35.25 multiplied by negative. So what was it at the bottom? It is 50 multiplied by 50, so it's 2,500, and then multiply by 2, so you have 5,000. So this is 9 over 5 actually, and then 0.015 multiplied by 90, you got this one as 1.35, so you have 2.35 with a negative. Okay, so all the 1,000 cancelled, so you have 9 over 5, which is 1.8. This is negative 1.8. So we have 35.25 multiplied by 1.8. You have negative 63.45 minus 2.35, which is, you end up with 65.8. Okay, with all negative sign. Okay, with all negative sign. What does this mean? What does this mean? If the price per camera, right? If the price per camera increasing by $1, okay, let's say $1, okay, by $1 from 50, but the price of the film keep it to be 4, the cost of producing, okay, the cost of producing camera and the film will decrease, okay, will decrease by $65.8. Why is that decrease? Can you guess? Because if the price of the camera going up, people don't buy it, right? Okay, the demand will be decreasing. So if the demand decreasing, you don't have to produce that much as previously, is it? So it means that the cost of production will decrease as well. Okay, are we good? Okay, this is the interpretation. So we are going to stop our clip right here at this example, and then We'll continue with some other thing about a multivariable calculus next time. So we'll see you then. Bye bye.